In this talk, I'm gonna describe what we have done on top of Node-RED, Grafana, and InfluxDB to build large-scale, high-speed, high-volume data solutions. This is a short version of the talk that I've done sometime in the past. If you wanted to see a longer explanation, please click on that video in the link. This is our technology stack. We start with using Grafana for the user interface. In Grafana, we'll talk to Prescient Designer, which is our distributed data workflow builder. And Prescient Designer can communicate with many Prescient Edge instances, which can be deployed to the edge, or they can be deployed in the cloud in virtual machines through Amazon MQ, which is based on MQTT. And there is a Influx database that we use, both as a cloud persistent storage and also for local storage. Our customers can insert their own layers in here. For example, some customers would replace the Grafana-based UI by their own web app. Some customers would replace InfluxDB by their data warehouse. So it's fairly flexible. This technology stack is called the MING Stack, M-I-N-G, and it's very popular, but very few companies have been able to build very large scale and high performance data solutions on this. So here I'm going to describe what we do to make that happen. So on the UI layer, we have added ability to input forms, buttons, dynamic panels, dynamic content on top of Grafana. Basically, our goal is to move toward web application capability, but still, within a very fast, rapid dashboard development framework. So we can develop pretty complex dashboards, interactive dashboards within a couple weeks. And this is how we access data. And this is a part of the key technology to remove the data bottleneck. Essentially, instead of traditionally accessing the database directly from Grafana, we send queries or commands into Prescient Designer. And Prescient Designer can expand those commands into additional queries, execute additional complex workflows, and then access InfluxDB. So this enables us to execute very complex type of functionalities from Grafana API. And in addition, because the amount of data we support is usually very large, typically database becomes a bottleneck. And we have implemented a shadow, which is kind of like a cache for the database. We have implemented rate limiting, which spreads the queries over time so that you do not, create too much instantaneous demand on the database. We have created distributed database architecture. And so a lot of work is done here in order to distribute the queries to make the system performant. From the Prescient Designer perspective, obviously one of the key goals, as a lot of people know, is to be able to assign many locations for the block to execute. This allows users to scale to thousands of instances at the edge or in the cloud. But in addition to that, a lot of work is done to enable customization. This is because in industrial systems, every site is different. There's different number of equipment, different models of equipment, and there's a lot of customized requirement for different sites, per different customers. So being able to configure the system differently for every site or every device is pretty critical. And so we have put a lot of effort into that. In addition, this has a seamless edge cloud integration. For example, this block here is running in the cloud. This is a communication link sending data. This is running at the edge. And then the results can come back to be printed in the cloud if you choose to. So that makes it a lot easier to implement and test large-scale systems. Now, on the edge side, performance is key. This is because we acquire data that are at 10 kilohertz or above. We acquire data that's like, thousands of data tags running at, say, 1 second polling rate. So in order to meet those type of performance requirements, we really have to optimize the performance of the data blocks down to single CPU cycles. And in addition, we spend a lot of time improving the security and network connectivity type of issues that we typically see in industrial edge systems. So in summary, while the MING Stack is great for building either prototypes or simpler solutions, the last 20% of the work to push it into large-scale systems is very difficult. And this is what we do to help our customers to conquer that challenge. And the reason that we chose the MING Stack is because it's drag and drop, it's rapid implementation, it's very visual. So overall, our customers have a visual solution that they can track over time, and they can also learn how to get, proficient at building this type of solutions themselves. If you want to see a more detailed explanation of all the features, please check out the full-length video in the link below. Thank you.